Hi, everybody. Welcome to section 4.3, where we'll be talking about differentiating logarithmic functions. So, a logarithmic function is of the form natural log of x. And so the derivative of natural log of x is just going to be 1 over x. Okay, so whatever is inside, this is just an x. What it's going to do is just drop down to the denominator. It will just be 1 over x. So let's go ahead and apply that to an example. So for the equation f of x equals 12x to the fourth times natural log of x, we want to find the derivative of this function. So here we have two functions multiplying each other, natural log of x and 12x to the fourth. So I'm going to need the product rule. So product rule, if you could recall, is f g prime plus g f prime. So we could go ahead and pick our f and g. So in this question, our f is 12x to the fourth. F prime is 48x cubed. G is natural log of x. And g prime, as we saw before, is 1 over x. Okay, so let's go ahead and put this all together. So f prime of x is going to be f times g prime. So 12x to the fourth times 1 over x plus g, natural log of x, times f prime, which is 48x cubed. Okay, so we can simplify this a little bit. We'll have 12x to the fourth over x plus 48, just rewriting this a bit, x cubed, natural log of x. And so this x cancels out, that to fourth cancels out, becomes a 3. So what I'm left with is 12x cubed plus 48x cubed, natural log of x. And something I could factor out just to clean up this solution is a 12x cubed, because both of these have an x cubed and 12 goes into 48. So I'm left with 12x cubed factored out, and what I'm left is 1 plus 4 natural log of x. And that would be my derivative. Oops, let me write that. Okay, so that's us using a natural log derivative and a product rule and a little refresher on product rule. So here's part B, tangent line at x equals z. I want to skip that for now and move on to a chain rule of logarithmic functions. So chain rule for logarithmic functions is described as such, where whatever is inside of that natural log goes down to the bottom, and we also multiply by the derivative of that inside. Okay, so here's a simpler example. So example, f of x equals, let's say, natural log of 2x. Okay, so the derivative of that is going to be 1 over 2x times the derivative of 2x, so times 2. So this would just be 1 over x, as those 2's cancel out. But that's essentially how the chain rule for logarithmic functions works. Whatever's inside of the natural log drops down to the bottom, and then you multiply it by its derivative. Okay, so let's go ahead and try out this example here. We want to differentiate y equals 2 natural log 3x squared minus 1. So we're going to need the chain rule for this, the logarithmic function. So y prime is going to be, the 2 is just a coefficient, so it stays the same. 2 times 1 over whatever's inside of the natural log. So this would be 3x squared minus 1. And we have to multiply by the derivative of the inside, whatever is on the denominator. So we have to multiply by the derivative of 3x squared minus 1. So the derivative of 3x squared minus 1 is just 6x. Okay. So if we could simplify this a little more just to clean it up, and what we're left with is this 2 and this 6x can multiply and become 12x all over 3x squared minus 1. And that would be our derivative. So that's one example of a chain rule. Now let's go ahead and check out another example of a chain rule using logarithmic functions. So differentiate y equals natural log of 1 minus 2x cubed. So this one's a little different because we have this cubed on the outside of the natural log. First thing we have to do is still treat it normally, where we just drop whatever is that natural log down in the denominator. So we have 1 over 1 minus 2x cubed. But the next step to do is take a derivative of that 1 minus 2x cubed. And so what that would be is 3 times 1 minus 2x squared times a derivative of that inside, which would just be -2. So in this case, as if you notice, is a double chain rule. Because we had one here and we had another one here, another chain rule here. So we can simplify this out and have three times -2. So -6, 1 minus 2x squared all over 1 minus 2x cubed. And notice that we can now cancel out 1 minus 2x squared and cancel out that third exponent on the same expression. So what I'm left with is -6 over 1 minus 2x. And that would be my derivative. So this is a double chain rule example where we have one here and then another one there. Okay, so let's keep going. We have another example, y equals natural log of 5x to the third. So this one is different than this example because the third is to the 1 minus 2x, where the third is to the whole natural log. So we would have to treat this a little differently and treat it like a power rule. So what would happen here is that 3 would drop down. So y prime is 3 natural log of 5x squared, right? 3 drops down, subtract 1, times the derivative of whatever is inside, so natural log of 5x. And the derivative of that natural log of 5x is 1 over 5x. And we're still not done because we need to take a derivative of 5x. So this would be times 5. So this is another double chain rule example. And so what you're left with is 15 natural log of 5x squared over 5x. And this 15 and this 5 can cancel out. And what you're left with is 3 natural log of 5x squared all over x. Okay, so that is an example where the natural log chain rule happens in the following steps and not in the initial steps, but still applying it. But okay, so let's go ahead and look at this last example. Differentiate f of x equals 5x over natural log of 2x cubed. So here we have two functions dividing each other. We want to find the derivative of that. So here's where we're going to use, or where we're going to need the quotient rule. And if you could recall, the quotient rule is g f prime minus f g prime all over g squared. So go ahead and pick out your f and your g and find the respective derivatives. So f is 5x, f prime is 5, g was natural log of 2x cubed, and g prime would be 1 over 2x cubed times the derivative of 2x cubed, so 6x squared. And so we could simplify this a bit. So x squared over 2x cubed. This x squared cancels out. This 2 could cancel out. And so what I'm left with is 3 over x, as this cube cancels out as well. Okay, so let's put this all together in this different derivative. So I would have f prime of x equals g, which is natural log of 2x cubed times f prime, which is 5, minus f, which is 5x, times g prime, which is 3 over x, all over g squared. So natural log of 2x cubed squared. Okay, so we could simplify this out a bit. So we have natural log of, excuse me, we would have 5 natural log of 2x cubed minus 15x over x, because of 5x times a 3 is 15x, and it's just all over this x. And this is all over natural log of 2x cubed squared. And so these x's cancel out. And what I'm left with is 5 natural log of 2x cubed minus 15 all over natural log of 2x cubed squared. Okay. And that's our answer. So these are different situations of deriving logarithmic functions, some naturally and some with the chain rule or double chain rule. But that's it for this section. I'll see you next time. Thank you. Bye.